The proliferation of hateful memes on social media platforms has necessitated the development of effective detection methods. Existing two-stream approaches, which rely on separate processing of image and text modalities, are becoming increasingly obsolete as new memes emerge, incorporating progressive cultural ideas. To address this limitation, the authors propose Evolver, a novel method that leverages chain of evolution prompting to enhance the performance of large multimodal models in identifying hateful memes. Evolver simulates the evolving and expressing process of memes by retrieving top-case similar memes and summarizing semantic regularities between paired memes for prompting. This process amplifies in-context hatefulness information, enabling the model to better capture the nuances of hateful content. The method is evaluated on public datasets, including FHM, MAMI, and Huang, demonstrating improved performance compared to state-of-the-art approaches. The authors argue that Evolver serves as an interpretive tool to understand the evolution of social memes, providing insights into the dynamics of online hate speech. By analyzing the chain of evolution, researchers can identify key factors contributing to the spread of hateful content and develop more effective strategies for mitigation. The proposed method has significant implications for the development of more robust and accurate hate speech detection systems, ultimately contributing to a safer online environment. The experimental results show that Evolver outperforms existing methods, achieving improved accuracy and F1 score on all evaluated datasets. The authors also provide a detailed analysis of the results, highlighting the importance of chain of evolution prompting in enhancing model performance. Overall, the study demonstrates the effectiveness of Evolver in detecting hateful memes and provides a valuable contribution to the ongoing efforts to combat online hate speech. The proliferation of internet memes has created significant challenges in detecting hateful content. Traditional methods for hateful meme detection suffer from limitations in interpretability and adaptability, hindering their effectiveness in the dynamic and evolving real-world meme landscape. To address these limitations, the authors introduce Evolver, a novel approach that leverages large multimodal models, LMMs, for hateful meme detection. The authors establish an LMM-based zero-shot hateful meme detection benchmark, which provides a comprehensive evaluation of the application of LMMs in social media. They propose a simple yet effective Evolver framework, which advances LMMs with chain of evolution prompting. This approach expands LMMs with an evolution reasoning ability while offering good interpretability. The authors discuss the potential of LMMs for hateful meme detection and introduce a knowledge-enhanced LMM, Evolver. They highlight the capabilities of groundbreaking models like GPT-4v and LLaVA 1.5 in interpreting complex datasets that include a combination of text and images. However, they also address the challenges these models face, such as sensitivity to noise and typographical errors, and the ongoing efforts to improve their accuracy and robustness in real-world applications. The authors adopt LMMs to hateful meme detection and set an LMM-based zero-shot hateful meme detection benchmark. They show that their Evolver further boosts the LMM's performance. They also present a novel chain of evolution prompting strategy to seamlessly boost the existing LMM for hateful meme detection. The authors define the task of hateful meme detection as a binary classification task, where a meme consists of an image-text pair. They introduce the proposed Evolver, which leverages a multimodal model to predict whether a target image-text pair is hateful or not. They describe the large multimodal models, which use a vision encoder to help language models understand visual content. They also describe the large language model decoder, which generates a sentence given tokens. The author's approach is based on the concept of prompt-based learning, which has evolved significantly from its inception with large language models to its current application in various tasks. They present a novel chain of evolution prompting strategy to seamlessly boost the existing LMM for hateful meme detection. The author's contributions include establishing an LMM-based zero-shot hateful meme detection benchmark, proposing a simple yet effective Evolver framework, and demonstrating the effectiveness of their method across 3 widely recognized hateful meme detection datasets. Their approach advances the state-of-the-art in zero-shot hateful meme detection and provides a more explainable and adaptable framework suitable for the evolving landscape of Internet memes. The chain of evolution (CO) prompting method is designed to enhance the performance of large multimodal models, LMMs, in detecting hateful memes. This approach leverages the evolutionary relationships between memes to improve detection accuracy. The co-prompt consists of three components: evolutionary pair mining, evolution information extraction, and contextual relevance amplification. Evolutionary pair mining identifies relevant candidate memes by exploiting the property that evolved memes share similar textual and visual semantic regularities with their predecessors. This is achieved by generating textual and visual embeddings from an external meme pool and target memes using clip, and then fusing the embeddings with a fixed ratio. The top K similar memes are retrieved using cosine similarity, and for each evolution meme, K memes that the evolution meme is derived from are paired. The evolution information extractor summarizes the paired memes using a large multimodal model, with the goal of extracting information such as hateful components. This process involves feeding the paired memes and an instruction to guide the LMM to extract information. The instruction is designed to extract the common harmful features of the image caption pairs based on predefined hatefulness rules. The contextual relevance amplifier enhances the in-context hatefulness information by adding a contextual relevance amplifier to the LMM during evolution information extraction and final prediction. The amplifier is defined as the definition of a hateful meme given by the dataset used, and is combined with the extracted information to feed to the model. The co-prompting method is evaluated on 3 public datasets, and the results are compared to baseline models, including API-based and open-source LMMs. The evaluation metrics and settings are described, and the results of the ablation study are presented. The paper also introduces the LMMBASED zero-shot hateful speech detection benchmark, which is used to ensure a fair comparison between the co-prompting method and the baseline models. The co-prompting method has the potential to enhance the ability of LMMs to understand hateful memes and improve their detection accuracy. However, it relies on the availability of a large external meme pool and target memes to generate textual and visual embeddings. Additionally, the method assumes that the hatefulness rules defined in the dataset used are accurate and comprehensive. Future work could focus on improving the co-prompting method by exploring different architectures and training strategies, as well as applying the method to other tasks, such as multimodal sentiment analysis and visual question answering. Key equations and algorithms used in the co-prompting method include: equation 5 memes equals I cos A B I element of top K cos A B. Equation 6 info equals LMM meme stop ike zextract. Equation 7 Y equals LMM memes target xdetect info amplifier. These equations and algorithms are used to extract evolutionary information, amplify contextual relevance, and make final predictions. The experimental results of the proposed evolver model on zero-shot hateful meme detection benchmarks are presented, comparing its performance with various state-of-the-art language multimodal models, LMMs. The evaluated models include API-based models Gemini Pro V and GPT-4V, as well as open-source models OpenFlamingo, LLAVA 1.5, MMICL, Mini GPT-v2, BLIP2, and Instruct Blip. The results, presented in Table 2, demonstrate the performance of each model on 3 datasets, FHM, MAMI, and HARM, using area under the curve, AUC, and accuracy, ACC, as evaluation metrics. Evolver outperforms all other models on the FHM dataset, achieving an AUC of 63.5 and an ACC of 63.6. On the MAMI dataset, Evolver achieves an AUC of 68.6 and an ACC of 68.6, comparable to the performance of API-based models. On the HARM dataset, Evolver achieves an AUC of 67.7 and an ACC of 65.5, surpassing the performance of all other open-source models. An ablation study evaluates the effectiveness of the 3 components of the Evolver model: evolution memes, evolution info extractor, and external curated meme pool. The results, presented in Table 3, show that the combination of all 3 components achieves the best performance on the FHM dataset. Figure 2 presents example results of the Evolver model on 2 memes, demonstrating its ability to correctly classify hateful and non-hateful memes. The baseline model, MMICL, and related models, including Mini-GPTV2 and BLIP2, are briefly described. The experimental settings and hyperparameters used for the evolver model are detailed in section 4.1. The model is implemented based on MMICL and LLAVA 1.5, with hyperparameters set for minimum and maximum length for generation, temperature, and maximum generated tokens. The authors investigate the effect of the ratio of textual and visual fusion on the evolver model's performance, finding that a 4:1 ratio of textual to visual embeddings achieves the best performance. The importance of the external curated meme pool is discussed, highlighting the need for it to have two characteristics: not overlapping with the test set and having enough evolutionary information. The experimental results demonstrate the effectiveness of the evolver model in detecting hateful memes, with a detailed analysis of the model's components and experimental settings, as well as a discussion of the results and their implications. The authors evaluate the proposed evolver method for hateful meme detection on 3 public datasets: Facebook Hateful Meme Dataset, FHM, Harmful Meme Dataset, HARM, and Multimedia Automatic Misogyny Identification, MAMI. Accuracy, ACC, and area under the ROC curve, AUC, serve as evaluation metrics. Evolver is implemented based on MMICL and LLAVA 1.5, with details provided in the appendix. The results show that Evolver consistently outperforms open-source LMMs models across all datasets and metrics, achieving higher accuracy and AUC scores. An ablation study analyzes the contributions of different components of Evolver, revealing that evolutionary pair mining, EPM, boosts the baseline by up to 2.3%, while the evolutionary information extractor, EIE, and contextual relevance amplifier, CRA, significantly improve generalization ability. The full evolver model achieves the best performance, outperforming the baseline by 8.5% in accuracy. Qualitative analysis visualizes paired evolution memes retrieved by the evolutionary pair mining module, demonstrating how evolution information influences the final prediction. Evolver requires minimal computational resources and can be seamlessly integrated into LMMs in the inference state. Experiments are conducted on 1GTX309024G or 1A10040G for the main results and 1A10040G for the ablation study. The authors also analyze the impact of the number of evolutionary memes on Evolver's performance, finding that their method significantly improves the baseline under all settings, achieving the best performance with 5 evolutionary memes. Additional case analysis demonstrates Evolver's effectiveness, highlighting improvements over the baseline model. The authors conclude that Evolver is an effective method for hateful meme detection via chain of evolution prompting. They acknowledge potential limitations, including concerns about privacy, censorship, and biases within the AI model, and provide an ethics statement and reproducibility statement. The authors present a qualitative analysis of the evolution memes dataset, showcasing the effectiveness of their proposed evolver model in detecting hateful memes. The dataset consists of image caption pairs, where the task is to classify the meme as hateful or non-hateful. The authors highlight several examples where the evolver model correctly identifies hateful features, whereas the baseline model, MMICL, fails to do so. In the first example, the evolver model detects the use of the derogatory term, HID, in the captions for images 2 and 4, which is a hateful feature. The authors emphasize the importance of using respectful and inclusive language when describing people with disabilities. The evolver model correctly predicts the meme as hateful, whereas the baseline model predicts it as non-hateful. In the second example, the evolver model identifies the use of derogatory language and stereotypes to demean and discriminate against women. The authors note that the use of such language promotes discrimination, objectification, and violence against women. The evolver model correctly predicts the meme as hateful, whereas the baseline model predicts it as non-hateful. In the third example, the evolver model detects the use of offensive language and derogatory remarks towards women. The authors stress the importance of promoting respectful and inclusive language in all interactions. The evolver model correctly predicts the meme as hateful, whereas the baseline model predicts it as non-hateful. In the fourth example, the evolver model identifies the use of derogatory language and offensive humor related to sex, gender identity, and sexual orientation. The authors highlight the importance of being respectful and considerate when communicating with others. The evolver model correctly predicts the meme as hateful, whereas the baseline model predicts it as non-hateful. Figure 4 presents example results of the evolver model and the baseline model, demonstrating the effectiveness of the evolver model in detecting hateful memes. The author's qualitative analysis highlights the importance of using respectful and inclusive language, and the need for models that can effectively detect hateful features in memes. The author's analysis assumes that the use of derogatory language and stereotypes is a hateful feature, and that promoting respectful and inclusive language is essential. The limitations of the study include the reliance on a specific dataset and the need for further evaluation on diverse datasets. Future work could involve exploring the use of multimodal models that incorporate both visual and textual features to detect hateful memes. The chain of evolution prompting approach for hateful meme detection using large multimodal models has shown promise, but its effectiveness is heavily dependent on the quality and diversity of the curated meme pool. The representativeness and comprehensiveness of this dataset are crucial, as inherent biases can impact the model's ability to generalize across different cultural contexts and meme evolution patterns. Hateful memes can manifest differently across various cultural and social contexts, and the model's performance may be compromised if it is not exposed to a diverse range of memes that reflect the complexities of online discourse. The approach involves using a large multimodal model to generate a chain of evolutionary memes, which are then used to fine-tune the model for hateful meme detection. This leverages the model's ability to learn from evolutionary patterns and relationships between memes, enabling it to better detect hateful content. The results, presented in Figure 3, show that the chain of evolution prompting approach outperforms baseline models in detecting hateful memes, with significant improvements in accuracy and F1 score. An analysis of the model's performance on different types of memes, shown in Table 2, indicates that the model is effective in detecting hateful memes across various categories, including image-based and text-based memes. However, the authors acknowledge that the curated meme pool may not capture the full spectrum of hateful memes, which can evolve rapidly and take on various forms. This limitation highlights the need for ongoing data curation and model updates to ensure the approach remains effective in detecting hateful memes. The chain of evolution prompting approach offers a promising solution for hateful meme detection using large multimodal models. However, careful consideration must be given to the limitations and potential biases of the approach to ensure that the model is effective and fair in its detection of hateful content. I'm ready to refine the transcript. However, I don't see the original content provided. Please paste the original text, and I'll transform it into a concise, technically accurate summary suitable for voiceover narration, following the guidelines you specified.